Today we're going to learn geometric proofs by looking at a couple examples. So the first thing you want to do whenever looking at a proof is look at your given. The given is E is the midpoint of DF. So let's just refresh our minds on what a midpoint is. A midpoint is literally the middle point of a segment. So if you have a midpoint, that just means these two sides are going to be equal and things like that. Since that's the first thing you want to put in your proof, the reason for putting it there would be it's your given. It's given to you. And you know the definition of a midpoint, which is that these two are equal. So you just want to say DE is equal to EF. So 6x plus 5 is equal to 8x minus 1. The reason for this would be substitution property of equality. Because you're substituting these lengths with their numbers in order to solve them and turn it into a more algebraic proof. And you can see that they just further solve this by subtracting 6 from 8 on the other side, so that would be your subtraction property of equality. To further solve this, you're going to be adding 1 to the other side, so that would be because of your addition property of equality. And now to isolate the variable, you're going to be dividing both sides by 2, so that would be your division property of equality. Now you're just going to state the equation that will give you DE equals 23, and that one would be DE equals 6x plus 5, which you already knew that DE equaled over there. So then the reason for that would be given because it was given in the picture. Now you just want to plug in your 3 that you found previously. So whenever you plug something in, it's going to be because of the substitution property of equality. In this case, sometimes it will be congruence when we're talking about lengths and not like actual numbers, but in this case, since we're talking about numbers, it's going to be property of equality. And now that you have all your numbers, you just want to plug them in. Since they're similar and they don't have any exponents or variables, then we're going to combine our like terms to get 23, and the reason is combine like terms. Since we ended our proof, we're going to end with QED, and we are done. To solve geometric proofs, you're going to need to know properties of congruence. Your first one is the reflexive property of congruence. That would be OA is congruent to OA. You're basically saying that something is congruent to itself. Now for symmetric property of congruence, that would be if BO is congruent to CO, then CO is congruent to BO. The last property of congruence is if BO is congruent to CO, and CO is congruent to AO, then BO is congruent to AO. This is called your transitive property of congruence. Now let's learn some theorems. So your vertical angle theorem is that all vertical angles are congruent. So 1 would be congruent to 2, and I've heard you a 3 and a 4 here, then 3 would be congruent to 4. So let's solve this proof. We know that angle 1 is congruent to angle 4 because it's given, and we also know that angle 4 is congruent to angle 2 because of our vertical angles theorem, and now we can just cross out the middleman, which is also known as the transitive property of congruence, to get that angle 1 is congruent to angle 2. We also know that angle 1 is congruent to angle 3 using the vertical angles theorem. So now we just have to cross out the middleman again to see that angle 2 is congruent to angle 3, and that is our proof. So let's go through our proofs. So the first proof is if two angles form a linear pair, then they are supplementary. So that would be saying that 1 and 2 are supplementary because they form a linear pair, which is this, and that's because if a line is really straight, then it should be equal to 180, so the angles that make it up should add up to 180. And this is called our supplement theorem. The second theorem is if the non-common sides of two adjacent angles form a right angle, then they are complementary. So it's saying that if these two sides form a right angle, then they are complementary. And this is called your complement theorem. So our congruent supplements theorem is if two angles are supplementary or congruent to the same angle, which would be 2 in this case, then they are congruent. So the congruent complements theorem is if two angles are complementary to the same angle or to congruent angles, then they are congruent. And here you can see that angles 4 and 6 are complementary to 5, so 4 and 6 would be congruent. So let's do another proof. We know that the measure of angle ABD is equal to the measure of angle CBE by the given, and we want to show that the measure of angle 1 is equal to the measure of angle 3. Well, we have to look at why they gave us this given. So the measure of angle 1 plus the measure of angle 2 is going to be equal to the measure of angle ABD because of the angle addition postulate. These two angles are the ones that make up ABD. The same thing goes for the measures of angles 2 and angle 3 making up the measures of angle CBE. It's all because of the angle addition postulate. Now, since you have already established that the measure of angle ABD is equal to the measure of angle CBE, you can use transitive property of equality to say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. So it would basically look like this. And now I'll just use the subtraction property of equality to say that the measure of angle 1 is equal to the measure of angle 3.